Okay, in this video, I'll talk about how to finish this computer simulation homework. So you need to follow this 3 or 4 procedures. I think you can finish it in half an hour or not more than 1 hour. So the first step is to download the QuickField student version at this link. So you can just go to here, and then you can just select QuickField Student Edition 6.4 and then fill in the name, university name, country, email, phone number. This one doesn't need to click. And then email address. I learned from, maybe you can fill in my name here, and then application, maybe just finish the homework, and then you click agree, and then I'm ready to download. And you jump to another page, and then you can start to download the QuickField Student Edition 6.4. After you finish it, and then you can start to install in your computer. So after that, you can open it in the start menu, like here, QuickField Student 6.4. After you open it, it will look like this. And so in this case, you already finished step 1, which is to download and install the QuickField. And then next, you try to follow this YouTube to finish to build up this model. We have 2 current. One current is going into the page at this point, and then another current is going out of the page, 100 millimeter from it. And so we would like to find the B field at point P. Okay, so so, or you can also take a reference from this attached PDF file. I will also send this to you. So I've made a few modification because the direction is opposite to what I have drawn here. Actually, I modified from here so to have an opposite direction of the current. Actually, the negative current means going into the page. The positive current means going out of the page, so that the x-axis point to the right side and the y-axis point to the pointing upwards, and the z direction is going out of the page, so it follows the right-hand group. Okay, so we can try to build this circuit in the QuickField. So here we try to click new on the top left. So here we can try to enter a name. Maybe we can call it BO Savat. Savat Law. Like this. BO Savat Law, or maybe you can pick a name you like. So we don't need to choose other thing. So next, here we can choose magnetrostatics here, and then meters, Cartesian, normal, we don't need to modify, plane parallel, we don't need to modify, 1 meter, and then we don't actually need to modify anything, and then we can click OK here. So it will jump out a BO-Savat-Law.mod, the model. So now we can build our model here. So first of all, we can try to click this button, Insert Vertex or edges, this button. So this button will be highlighted, and then we can right click on any point here and then can click add vertex. At 0, 0, we add a point so that we can see a point, a green point is at 0, 0, like this. And then next, we can add a point at 0.1 meter, 0.1 meter, which is which is actually 100 millimeter, which is a 0.1 meter. So we add another vertex at this point, which is here, and also we'll like to add another point P. Add another point P, which is 50 millimeter higher than this point. So this point should be 0 and 0.05 meter, like this. So we click add and close it. And then we may also click fit to zoom so that we can see this point is 0. This point is 100 millimeter. This point is 0.05. So in this case, we can like this. So we can click select object, and then we can select this one, and then right click on it, and then select property. Now we can enter a name like I-, which specify the current going into the page, which is a negative current, and then we click OK. So here on the left side, we can see under the vertex labels, we have I-. Like similarly, we can also click on these points, and then right click on it, and then click property. And then we can call it I+ to specify it is a positive current. So we can also see I+ is here. And also we can click on this point and right click on it and then click property. So this point is the point P. Actually, we don't really at this point, but I just follow what the tutorial video. Actually, here is you can also check. You can also check the tutorial video, but actually, it demonstrated on the full version, so that if you totally follow him, then you may not be able to finish it. So yeah, so I just have the point P, so you can see point P is here, and then we also need to specify the region to calculate. So maybe we can just click insert vertex or edges again, and then right click on the screen and click add vertex. Now we may be able to add a point at 1 meter, 1, 0 add, and then also we add another point -1, 0, and then click add and then close, and then we click zoom to fit so that we can see another 2 points. This one is -1, 0. You can see the bottom right corner to show the coordinate of the point I am pointing, that the cursor is pointing to. So this is a -1, 0 meter, and this point is 1 meter, 0 meter for the y coordinate. So now we need to draw a circle. And then we can click insert vertex again, and then click here this lower triangle, and then select half arc. And then we can drag from this point to that point. Yeah. Then we can draw a semicircle. And then we drag from -1, 0 again to 1, 0, so that we draw another half circle. So we can also click zoom to fit again. Now we have a circle here, which means this is the region we concern. And then this is the negative current, this is the positive current, this is the magnetic field we concern. So yeah, so now we click select object again, and then we can select this one, and then you press the control and then click this one, so that the whole circle is red. If you just select one, then you'll see this one is red, this one is blue. And if you press control, if you don't press control and then you click on this line, then you only select this half circle. So you need to press control and then select both, and then you right click on it and click property. You rename it as boundary. So that under edge labels, we have a boundary here, and then you can left click on the circle, so the whole circle is highlighted in red, and then you right click on it and then click properties, and then we can rename it as air, so that this area is only air. There are no conductor here. Okay, so you can also see that for the block labels, we have air. So after finishing this, we can double click on air. It will jump out these windows, and then for the permeability, we can enter 1. Then all the other will directly change, and then you don't need to modify anything else, and then click OK. So this air will change from yellow to red. Okay, and then the next, we click on the boundary. Double click on the boundary, and then it jump out these windows, and then you click this checkbox, and then it will show 0 here, the magnetic potential, and then click OK. So this one also changed to blue color, and then next we double click on the I-, and then we check this box, linear current, and then we enter -10 ampere, and then click OK. And then next, for the I+, we double click on it. We also choose linear current, and then we enter 10 ampere here, and then click OK. P, we doesn't need to modify anything. We just leave it there. So now we have built the model like this one. So we have this I-, this is I+, this is point P, and then we draw a circle there, so that it will try to calculate the B field within the whole circle. So next, we can just click here, and then we click this button, Build Mesh. Okay, so you can see there are many green triangle there. There are many green triangle. Yeah, so maybe you can also view the properties. View the properties. So you can see there are 196 nodes of mesh. And yeah, as long as this is the student version, so you cannot build the model to be too complicated. It is not allowed to have the mesh number larger than 255. And actually, if you really need to get a very accurate answer, then you hope this mesh to be as small as possible. And in this case, the nodes of mesh will be very large, which means that for the full version of the QuickField, then you can set it to be larger and larger, and you may even use this soft and refine function to get a more accurate answer. But of course, as long as we use the student version, then the answer will not be very accurate, but it's fine. It's just yeah, so this is just a homework to let you know how to use this kind of software. Okay, so after we build this mesh, we can start to click on this soft button on the top left. And then it asks you this file has been modified, problem model and DMS, and then actually you can just click yes. So Bill-Suffolk law problem has been solved in 1 second. Do you want to see the result? You click yes. Okay, so this is the result. And actually it shows the B-field line, if you, yeah. So you can click on this button here, field picture properties. And then you can click color map off. And then you also click show mesh. You click OK. So yeah, so and also you can click on the legend button, which means that if it is in red color, which means the B field is the strongest. If it is in blue or even purple, then the B field is the weakest. Is the weakest place. So we can try to click zoom in, because actually yes, actually the current is placed here and here. So so you can click this zoom in again to yeah, so that we deselect the zoom in, and then we can click local values. It will jump out this small window. Then we can try to click on any point. For example, if we click on this point, which is 0.006 and then 0.0002, then after I click here, then you can see 0.006, 0.002, and then it will show the magnetic field here. So Bx is the x-axis component, y-axis component, and the total magnitude. And of course, what we concern is the point at 0 and 0.5 meter, 0.05 meter, which is roughly here. So I click here. So it is near 0 and 0.05, but actually not very accurately. So I can just double click on here, and then I change this number to be 0. So you can see it changed to -0, and then I also double click on this one, and then I modify it to 0.05. So you can see here, -0, 0.05. which is actually this point we concern. So now we can see bx at this point is 3.7 times 10 to minus 5. And then minus 1.2 times 10 to minus 5 Tesla. And then the total flux density is, or B field is 3.97. Actually, if you just take reference on this one, you can see that if you try to use this formula, actually this formula is not really Biot-Savart law. Actually, it is already mu0I over 2 pi r. mu0I over 2 pi r. Actually, this can be derived from the Biot-Savart law, which is actually this equation. Actually, you can derive this one by the Biot-Savart law, but it is actually this one. So you can see here, if you calculate the B field in an analytical way, so you substitute the number. This is mu0 over 4 pi times 2 times this is the current, and then over R. So B1 and B2 you can calculate analytically, and then you calculate the total B field at 0.05 meter. So it is 3.2 and then minus 1.6. I think there are some typo mistake, because this is 0.5 meter, but actually this is 0.05. This is 0.1. So there is some typo mistake here. 1.1 is from this point to that point, which should be 0.111 like that. So there is a typo mistake there, which means this one is 10 times smaller than the correct value. But as you can see, for here is, it should be 32 mil Tesla. But what we calculate is 37.7. And then for BY, minus 16. What we get here is minus 12.5. So this is not very accurate, and as I mentioned before, the grid is too large. The mesh is too large, so the calculate answer is not so precise. Of course, for full version, we can use soft and refine to get a more accurate answer. However, this is the student version, so it will tell you that the addition of QuickField internal restrict the mesh size and does not supporting refining. So we may not be able to get the more accurate answer, but that is good enough for the homework. And and as long as this, you already get the correct model for this structure. And for this homework, you are requested to change I minus to minus 15A and I plus to 5A, and find the B field at 0.05 meter and 0.05 meter, and compare it with the analytical result. I think you can just simply follow this one. Just the only difference is that you change this to minus 15, change this to plus 5, and then the point you find is here, 0.05, 0.05, which is actually this point. So you can just click on this one, change it to -15, click on this one, change to 5, and then you click the solve again, and then you click yes, and then it will generate a new figures, and then you try to find the value at somewhere here. Then you can try to capture the value you find, and then you try to calculate the B field at this point analytically, and then you try to compare it. And this is good enough for this homework.